Alright, so I want to talk about the inverse sine function, also known as arcsine. And this can be a little confusing, and there's a lot going on the screen. Don't panic, I'll go through each piece step by step and hopefully make this all clear. And I'm going to kind of over explain this concept um, just so you fully understand it. Um, yes, I mean, you can type in um, the inverse sine on your calculator. You can take, on my calculator here, it's this is short for arcsine of anything, and just see what it is. But I want you to understand what you're really doing here, and see where you don't actually need a calculator in a lot of cases um, to find this. So, an inverse function in general is a function that undoes another function. So my just simple example here, um, 5 squared is equal to 25. So the square root of 25 is equal to 5. So squaring something and square rooting something are inverses of each other. If you take a number and square it, and then take the result and square root it, you get back to where you started, right? You've gone from 5 to 5. Okay. Um, so the square function and the square root function are inverses of each other. Okay, so similarly, sine and arcsine or inverse sine are functions that undo each other, in a sense. Um, okay, so what does sine mean in the first place? Well, a sine is a trigonometric function, and trig is just the study of the relationship between angles and the ratios of the sides uh, of triangles. So, for example, if I look at this angle here, theta degrees, sine would be the ratio of the opposite side, the length of the opposite side, um, over the hypotenuse. Okay? So if this side length is 3 and this side length is 5, then the sine of this angle is 3/5. That's all, right? Um, well, if I take the inverse of 3/5, the inverse sine of 3/5, then I get the original angle. So you can, here, let's put it up here. Sine of theta equals, in this case, just a simple example, whatever this angle is 3/5. Um, and then arcsine of 3/5 equals that original angle, theta degrees. Okay, so I've gone from theta back to theta. Does that make sense? Um, so, in other words, here's another way of saying it. If the sine of some angle is 3/5, then the question, so saying arcsine of 3/5 is, what angle do I need to take the sine of to get 3/5? Well, the angle is that original angle. Okay, so let's look at some specific examples where we figure out what these angles actually are. And so for some of these we don't need the calculator. I've created a table of the very standard degree measurements where there's um, very simple trigonometric ratios. So the sine of 0 degrees is 0, sine of 30 degrees is 1/2, sine of 45 degrees is square root of 2 over 2. So these are the values you'd see on a unit circle. So I've got these. So if we can make use of this chart, we'll do it, and then if we can't, we'll just grab the calculator. Okay. So I want to figure out what this angle is, theta. Okay. Well, I know that the sine of theta is the ratio of the side opposite to it. So the one that's across. Actually, let me switch colors. Hopefully you can see that a little better. So the ratio of the side that's across from it over the hypotenuse. I guess I should mark that these are all right triangles. Okay. So this is the hypotenuse. So we know that the sine, I'm going to switch colors again. Sine of theta is the ratio 1 to 2. So I could figure out what theta is by taking the arcsine of 1/2. Arcsine of 1/2. So the arcsine of 1/2 is asking the question, what angle do I have to take the sine of to get 1/2? Okay, well, here we go. The sine of 30 degrees is 1/2. So the arcsine of 1/2 is 30 degrees. Okay, so arcsine of 1/2 is 30 degrees. Or the sine of 30 degrees is 1/2. Alright, let's figure out this angle, theta. Different theta. It's not necessarily going to be 30 degrees. In fact, maybe it will be, maybe it won't. So the sine of, so start with what we know. We know the length of the side opposite to it, and we know the length of the hypotenuse. So opposite over hypotenuse is sine. So we're dealing with sine. So we know that the sine of theta is the ratio 3/6. So what is the arcsine of 3/6? Well, that's not on our chart, but don't rush to grab the calculator because let's reduce this ratio. What is the ratio of 3 to 6 equivalent to? Well, it's equivalent to 1/2. 3/6 is equivalent to 1/2. So let's call that 1/2. Well, we just figured that out. Arcsine of 1/2 is 30 degrees. So this is a 30-degree angle. So this triangle is similar to the first triangle. All right. Okay. Let's try another one. So we've got another angle here, and we've got the opposite side, and we've got the hypotenuse. So the sine of 2. So the sine of, theta is the ratio 2/11. So if we want to figure out what theta is, we could take the arcsine of 2/11, and that'll tell us the angle that theta is. Okay, 2/11 is not one of our easy little common values. So now we'll grab the calculator. So I'm in degree mode, so the answer, it'll give me the angle in degrees, so that's nice. On my calculator, it's ASIN is the abbreviation for arcsine. You might see sine like that. Sine to the negative first. That's a way to symbolize arcsine. I don't like that notation because it's confusing. But you might see that. Or it might be spelled out like ARCSIN. So we're going to take the arcsine of 2/11, and that is 10.48. 10.48 degrees. So the angle 10.48 degrees is the one where if I were to take the sine of it, I would get 2/11. Which is whatever decimal that is. 0.181818 repeating. Yeah. Alright, so that's inverse sine. I've got some for you to practice. So here's one based on a diagram, and then just some so the sine, the sine of take the sine of theta and figure out the arcsine of that result to figure out what theta is. And then here, these numbers just represent the sine of some angle. So take the arcsine of each one of these. If you can use the chart, use it. If you need a calculator, use a calculator. All right, good luck.